This is example 2. Okay, so the problem says that let f from R to R be defined by fx equals to 2x plus 1 for all x belongs to R. Show that f is a surjective function. How to show it? So first of all, let y belongs to R. That means this R is a codomain. So then fx equals to y implies what's the value of fx? 2x plus 1. Put it. So 2x plus 1 equal to y. So 2x equals to y minus 1. So x equals to y minus 1 by 2. Look at that. Here y belongs to R. So y minus 1 also belongs to R, because y belongs to R means y is a real number. So y minus 1 is also a real number, and hence y minus 1 by 2 also a real number. So that number belongs to R as y belongs to R. So x belongs to R. Got it? Now what is your conclusion? Thus, for all y belong to R codomain, there exists x belongs to R domain such that fx equals to, what is the value of x here? That is y minus 1 by 2. Put it here. So fx equals to f of y minus 1 by 2. So now look at that. What is the definition of fx? Fx equal to 2x plus 1. So this x is replaced by y minus 1 by 2. So that's why this x is replaced by y minus 1 by 2. So what happened? This is 2x plus 1. This means 2 into y minus 1 by 2 plus 1. Got it? So 2 cancel out. So y minus 1 plus 1. Y minus 1 plus 1. That is equal to y. Holds. That means for all y belong to R codomain, there exists x belongs to R domain such that fx equal to y holds. And this is a definition of surjective function. Hence f is a surjective mapping. Example number 3. Discuss the surjectivity of the following mapping f from z to z defined by fx equals to 2x minus 1 for all x belongs to z. Z means set of all integers. So how to show it? Let y belong to z. That means codomain. Take any element from the codomain. Then fx equal to y. So 2x minus 1 equal to y. So 2x equal to y plus 1. So x equal to y plus 1 by 2. Now clearly when y equal to 2, x equal to 2 plus 1 by 2, how much equal to 3 by 2, and that doesn't belong to z means codomain, means domain. That means we see that the element 2, because y equal to 2, the element 2 belong to z in the codomain, have no pre-image in z, that means domain. That means if you take y equal to 4 here, then x equal to how much? 4 plus 1 by 2, 5 by 2, that doesn't belongs to z means domain. That means if we take all even numbers which have no pre-image in the domain, that's why I write it. In fact, all even numbers in the codomain has no pre-image in the domain. But if we take y equal to 3, then x equal to 3 plus 1 by 2, that means 4 by 2, that is equal to 2, that belong to z domain. That means if we take all odd numbers, then which has the pre-image in the domain, but if we take all even integers in the codomain which has no pre-image in the domain, and that's why it is not a surjective function. Now example 4. Show that the function f from R to R defined by fx equal to 2x cube minus 7 for all x belongs to R is surjective. How to show it? Let y belong to our codomain. That means take any element y from the codomain, that codomain R. Then fx equal to y, this is a procedure. So 2x cube minus 7 equal to y, 2x cube equal to y plus 7, so x cube equal to y plus 7 by 2. So x equal to y plus 7 by 2 whole to the power 1/3, and that should belongs to R. So x equal to y plus 7 by 2 whole to the power 1/3 also belongs to R as y belongs to R. Got it? So thus for all y belong to R codomain, there exists x belong to R domain such that fx equals to, what is the value of fx? Put this one, put it here. Instead of x, the value of x is there, put it. So now what is the definition of fx? Here fx equal to 2x cube minus 7. Now instead of that x is replaced by this total one, y plus 7 by 2 whole to the power 1 third. So 2x cube, instead of this x, 2 into, instead of x is replaced by this one cube, x cube, because here is x cube, 2x cube minus 7. X is replaced by y plus 7 by 2 whole to the power 1 third. So that means 2 into y plus 7 by 2 whole to the power 1 third to the power 3, and that is minus 7. So this 3 cancel out, and that 2 cancel out. So y plus 7 minus 7 by, that means y. So fx equal to y holds. Thus what is the conclusion? Thus for all y belong to R bracket codomain, there exists x belong to R domain such that fx equals to y holds. Hence f is a surjective function.